Hello ladies and gentle ladies, and welcome back to another Minecraft modding tutorial for Fabric 1.21. And in this tutorial we're going to be creating an energy storage for our block entity. So let's go ahead and get started. So the first thing that we need to do for this tutorial is we need to add a dependency, and this dependency is called Tech Reborn Energy. And the reason we need to do this is because unfortunately Fabric does not come bundled with any kind of energy API, so we need to go ahead and add one ourselves, and the one that everyone seems to use is Tech Reborn Energy. So you don't have to have the Tech Reborn mod for this, you just need to have their energy API. So that's not too big of an issue and it's not going to be an inconvenience, so we're just going to go ahead and do that real quick. So first of all, we're going to come into our build.gradle, and at the very bottom here, inside of our dependency block, we need to have include mod API, and inside of here, we need to say team reborn :energy : and then we're going to say $, and we're going to open up some curly braces, and we're going to say project.energy_version. And then what we need to do is inside of our gradle.properties file at the dependencies at the bottom here, we're going to say energy_version is going to be equal to 4.1.0. Now I should mention that 4.1.0 is currently the latest for me, however it may not be the latest for you, and if you want to check whatever the latest version is, you can come to their Maven here and you can see that the latest is 4.1.0, and on the GitHub repo it will tell you which you should be using for your Minecraft version. So we're using 1.21 or later, so currently we need to be using 4.1.x. However, there may be a specific version soon where it may require that you use version 5, and that may not work for then 1.20.1. so just make sure you're using the correct version. The link to this will be in the description, and then from there you can just click here for the Maven repo. Then all we need to go ahead and do is click our Gradle reload button, or you can come to your Gradle tab and reload in there too. And what that will do is that will go ahead and rebuild. So if I open up the build window, you see that is just going to rebuild all of our dependencies, and all of Loom will start running there. Now, whilst that is doing that, I'm going to explain what we're going to be creating and what I've already added. So we're going to be creating an energy generator and an energy storage. The generator will just generate energy passively, so it's not going to require anything. And then the storage will just hold energy. And the idea is that we'll be able to generate it and it will automatically transfer energy to any other energy storages that are neighboring it. So that's going to be the plan, and it should be fairly simple. So I've just created the block classes here, nothing special. I'm just printing the energy on right click on both of these, and then in the block entities it's just a basic empty block entity with the generator ticking. The storage doesn't need to tick, so we're not going to worry about that. I should note, of course, that this tutorial will require that you have watched the previous two tutorials on block entities, so the block entities tutorial and also the ticking block entities tutorial, as both of those will be required here. I have also gone ahead and just done all the data gen, so that's just basic stuff, nothing too special there, and I've obviously added the textures as well. So what we can do now inside of our energy generator, we'll get started with that one first. We are going to want to create an energy storage. So we're going to create a private final simple energy storage, and I'm just going to call this energy storage. Now this will be equal to a new simple energy storage, and this takes 3 parameters. This takes the capacity, so I'm going to say that I have a capacity of 100,000, and by the way I'm just using an underscore to help indicate, you know, how big the number is. You obviously don't need an underscore, but I just think it helps for readability here. Then we are going to have the maximum insert. So this is basically the maximum that other block entities will be able to insert into yours. So I'm just going to put 0 since this is a generator, so we don't want other generators to insert energy into our generator. That doesn't really make any sense, so we want to say 0. The final parameter is the max extract, and that is how much other block entities can extract from your block entity. So I'm going to say 1000. Now, I should note that the way that Tech Reborn Energy works is that it is a push-based system, not a pull-based system. And what this means is that you can push your energy to neighboring block entities, but you should not pull energy from neighboring block entities. That's basically how it should work. So you should always push energy. You should never pull the energy from somewhere else. And that's just basically how the system works. And if you basically break that rule, then things could go a little bit haywire and you could have some problems. So you want to try and keep to that wherever you possibly can, and there should be no reason to deviate from it anyway, since it doesn't really matter which way around the system is designed. It's going to be able to function the same way anyways. Okay, now one thing we will want to go ahead and do is we're actually going to make this a little anonymous class here for the simple energy storage, and we're going to override on final commit. And basically what this is when the energy has been inserted into our energy storage, or basically when the energy changes, then we can do something, and this on final commit method will be called. So generally the thing you want to go ahead and do here is just mark your block entity as dirty so that it can be saved to the world. That's basically what you usually want to do. You may also want to go ahead and sync that data to the client. Now, we're not going to be covering syncing in this tutorial. That will possibly be the next tutorial, or maybe this tutorial after that. But for now, all we're going to do is just call mark dirty. And that will tell the game that this block entity has data that's changed and it needs to be saved. So do note that this is an irreversible action. Once this on final commit has been called, this is completely irreversible. So that is when the data is completely set in stone. And before that, the data is kind of not been set. It hasn't really changed until this method has been called. So inside of the tick method, we're just going to do some basic stuff in here, really. So we're going to say, for example, if this.world is equal null, or we are client, so this.world.isClient, then we're just going to return. Then all we're going to do is do a very basic energy generation method. And the way we're going to do that is we're going to say if energy storage.amount is less than the energy storage dot capacity -10, then we're going to do energy storage dot amount plus equals 10. So all that will do is, while our energy storage is not full, it's going to go ahead and generate 10 FE, or whatever energy units you wish it to be. The reason we're saying -10 is because we're generating an increment of 10. So if we had, the actual exact amount, that would mean it's possible for us to go over that, and we don't want that. The alternative obviously is that we could just use less than, and we could actually just set the amount to be mathhelper.clamp, and we can clamp that amount, so energy storage dot amount plus 10, and we can clamp that between 0 and the energy storage dot capacity. And actually we'll do that instead, just because that does mean that it's possible for us to potentially lose some energy there, but it also means that we can actually fill the energy up even if it's like 9 below or 3 below. It means that we can still fill that up and not go over. So I think we'll do that instead, and that's just a little bit easier. Then what you should do, since this has changed, we should call our mark dirty method. And you may think that this on final commit will be called. That's not in fact true. This on final commit will not be called, and that is because this only happens when there is a transaction that is inserting or extracting, and we're not inserting or extracting here. We are directly setting the amount, and therefore we need to call this mark dirty method. And before we continue with trying to spread our energy to the neighbors, let's go ahead and try and save this and read this to the MBT first. So inside of write MBT, all we're going to say is MBT dot put long, because the energy that is stored is a long, not an integer, and the long that we're going to store it as is just energy. And then we're just going to say this dot energy storage dot amount. Then inside of the read MBT, we're going to check if MBT.contains energy, and we're going to use MBT element.long type. If it contains a long with the name of energy, then we're just going to say energy storage.amount is equal MBT storage.getLong energy. And it is obviously very important that you name these things here the exact same thing, otherwise you will have mismatched reading and writing. Okay, and the final thing we need to go ahead and do is actually make sure we extract this energy to the sides. So how do we do that? Well, simply we're just going to have a for loop for all the directions, and we're just going to say for each direction we're going to try and extract as much as we can and then insert it into the neighbor. So I'm simply going to say direction.values, and I'm going to type .for, which will convert that to a for each loop. So for each direction in direction.values, we're going to try and first find the energy storage. So the way we do that is we say energy storage is going to be equal to energy storage.sided.find, and we will pass in this .world. We will also pass in the position that we're trying to find it as, which will be this.pos.offset direction. And then we're going to pass in the direction, which is going to be direction.getOpposite. So the reason that we are offsetting in the direction is because we want to get the block that is the energy storage, and that will be found at our position, then offset to the direction that we're looking at. And then the actual side that we want to find it on is going to be the opposite of the direction that we're looking at. So it should be the direction that the block entity is facing towards us rather than the direction we are facing towards them. Therefore, it is the opposite side. Then we're just going to check that the storage is not null, and also that the storage will support insertion, meaning that we can insert into that energy storage and that it's not like a generator, for example. Then what we are going to do is we are going to create a transaction, and if you remember from the previous tutorial, we do this in a try with resources. So we're going to say try transaction is equal transaction.openOuter. Then what we are going to do is we are going to try and extract from our block entity. So we're going to grab the maximum extraction amount. So that will be long max extraction is going to be equal to math.min between the energy storage.amount and 1000. And the reason we're grabbing the minimum is because 1000 is our max extraction that we set up here, and then the energy storage.amount is going to be the amount that is stored. And so basically we only want to limit up to the max extract, meaning it will just choose the smaller value of these two. Then we can go ahead and try and insert this into the storage. So we can say long inserted is equal to storage.insert, and then we're going to pass in the amount that we want to try and insert, and then we're also going to pass in the transaction. Then all we need to do is negate the amount that is inserted from our energy storage.amount. So we're going to do that. We're going to say energy storage.amount negative equals to inserted. Now, if this has happened, we ideally want to mark our storage as dirty. So we can create a basic Boolean flag up here to say, for example, has changed, which we can set to false. Then we can just say in here that has changed is going to be equal to has changed, or inserted is greater than 0. Then finally, after this for loop, we can just say if has changed, then we go ahead and mark dirty. Now, alternatively in here, instead of doing this whole math.min and then storage.insert, we could also directly go ahead and say that we are going to extract the amount that is inserted. So instead of what we had, all we have to say is this.energystorage.extract, and we can extract, so we'll extract 1000, for example, which is the maximum amount that we can try and extract, and then we can pass in the transaction, and then all we have to do is pass that into the storage.insert. So we can storage.insert that, pass in the transaction to there, and then all we have to say is transaction.commit. So what that will do is it will try and extract up to 1000 from our energy storage. So it'll basically get that clamping for us. It will handle that for us. So it will go up to 1000, and then using the transaction, it will then pass that down to this insert. So this returns the amount that it was able to extract, as you can see. So the amount that was extracted is a return from this, which will be passed into insert here. Now you will see that this insert will then return the amount that is inserted. So the problem with this is that it is possible that it can't insert the amount we're trying to extract, and therefore we will just lose energy and it won't actually go anywhere. So what we do want to go ahead and do is actually use some variables here once again. So we can say long extracted is going to be equal to our extraction, and then we're going to have once again long inserted is going to be equal to that with extracted, and then what we can just say is our energy storage amount will plus equal extracted negative inserted, and that would also go ahead and work as well. And the reason we don't need to now have the mark dirty is because we are committing the transaction. So what that will do is that will call our on final commit, which therefore calls mark dirty. Now you can choose to do either of these ways. It doesn't really matter which way you choose to do. I personally usually do the other way. However, I think this is maybe a little bit simpler to understand this way, so I think I'm going to keep it as this way. But once again, it's up to you. Whichever one makes more sense to you, you can choose to do. Now what we also need to go ahead and make sure we do is create a method to get our energy storage from our block entity. So we're going to say public simple energy storage get energy storage, and we're just going to return this dot energy storage. What we are also going to need is a public simple energy storage get energy provider, and this will take in a direction, and we can return our energy storage. So what this is used for is this will determine what direction our energy storage is going to be available on. So what side of our block it will be available on. So you could have, for example, a switch on direction, and depending on the direction, you could possibly return a different energy storage, or you could not return an energy storage at all. You could do those kind of things as well. Now we only have one energy storage here, so we're just going to return our simple energy storage. Now this will be used in the future as well, for example for fluids and also for our inventory, to have sided inventories and sided fluid tanks, which will be super neat. We will hopefully get to that very soon, possibly the next tutorial, which will be super handy. So with that done, that fixes our error in our block class, so we can go ahead and close both of those, and we can now do our storage block entity, which is going to be pretty much the same, except we're not going to have any kind of ticking. So we're just going to have a private final simple energy storage, which will be our energy storage, which is equal to a new simple energy storage. Then it's going to have our capacity. I'm just going to say we're going to have 1 million possible FE in here. The max insert, I'm going to say it's going to be 10,000, and then the max extract I'm also going to say is 10,000. Since this is a battery, we want it to be possible to extract and also insert from this. And then finally, we do need our on final commit as well, so we're going to mark that as dirty. Then we're also going to go ahead and read and write the energy, of course. So we're going to say if mbt.contains energy, and we're going to say mbt element.long type. Then we're going to say this dot energy storage dot amount will equal to mbt.get long, and we're going to pass in the energy. And then in write, this is going to be mbt dot put long. We're going to pass in the energy as the name, and then this dot energy storage dot amount. And then once again, we're just going to want those two getter methods as well. So a public simple energy storage get energy storage, which will return this dot energy storage, and then also the public simple energy storage get energy provider, which is going to take in the direction, and then it's going to return this dot simple energy storage as well. And with both of those done, we can now come into our main class, and we need to go ahead and register those energy providers. So for that, we're simply just going to say energy storage dot sided dot register for block entity. We're going to first go ahead and do the generator. So we'll say example energy generator block entity ::get energy provider, and we're just going to then pass in the block entity type from our block entity type init, and then we're just going to do the exact same thing for our battery as well. So we're going to say register for block entity, example energy, storage block entity, get energy provider, block entity type init dot example energy storage. So with all of that done, we can now go ahead and run the game, and we should hopefully be able to see that everything will work. Alright, so if we place down our energy generator here, and if we right click it, we can see that the energy is increasing. And if we place down a storage, you'll see first of all it has 0, but if we place it here, we can see that that is now increasing, and our energy from our generator is 0. And if we place it here, ideally it would obviously spread between the two, and it does actually seem to be not doing that. So effectively what it's doing is it's choosing the first direction that it gets to, so it's not generating to this one. However, for example, we could obviously have another one, and you see in that case this one is getting energy and this one is also getting energy because this one because this one is providing this one energy and this one is choosing this one. So effectively, because we are looping through the directions in our code, so if you quickly come in here, you can see what's happening basically. So for each direction, right, so that means it will start at direction north, and then it will say if there's a storage at north, then it will try extract and then insert into that storage. At the point that it's done that, our storage is now going to be empty. So when it gets to the next direction, say for example east, that means that it can't insert into east because there's nothing to extract, right? So this extracted will be 0, so it inserted will be 0, and therefore nothing changes basically. So that's basically what's happening here. And that's why it doesn't distribute evenly between the two. You could possibly have it distribute evenly if you had a different distribution algorithm instead of just directly going through each one by one. You could possibly pre-calculate how much to store into each one and then distribute that evenly. That's obviously a lot more complicated and too much for this tutorial, but you could definitely do that if you so wish. But anyways, that is going to be it for this tutorial. I know this is releasing a day later than usual. Normally, obviously, I release Tuesdays and Thursdays. However, I just got completely occupied yesterday and I didn't have the opportunity to deal with this tutorial, but it will release today, which is Friday. And hopefully the next tutorial will be next week on Tuesday. That is the plan. What it will be, I don't know as of current. I'm thinking possibly inventories, but I'm more inclined to do a GUI so that we can actually show the amount of energy that's stored in these in a GUI. And then after that, we will talk about syncing, because we need to sync. In fact, we might do that in the same tutorial, and then possibly inventories, because doing inventories without GUIs is a bit weird. So we won't probably do that. It will probably be GUIs first, and I also do hopefully plan to have the entity tutorial out next week too. I'm not going to guarantee that, but hopefully it should be, so that we can get that done and dusted. But yeah, if you found this tutorial useful, please do be sure to give it a like and subscribe. And if you have any problems, obviously you can join my Discord server, which is linked in the description below. And I will see you next time. Goodbye.